All right, let's just jump straight into it. Companies are pouring unbelievable amounts of money into GPUs. They're basically the new gold. But here's the crazy secret that nobody really talks about in the AI revolution. Most of that expensive gold, it's just sitting there, doing absolutely nothing. So today, we're going to break down this massive, billion-dollar bottleneck and talk about the super clever software that's designed to finally put all that power to work. Okay, I want you to put yourself in the shoes of, let's call him Ivan the IT admin. You just signed off on a GPU cluster that costs millions of dollars, and your CFO, well, she's already breathing down your neck about the ROI before the ink on the check is even dry. But when you pull up the dashboard to see all that amazing work happening, you see a whole lot of nothing, just idle hardware burning a massive hole in your budget. This is the question that keeps you up at night.
And this is why Ivan isn't sleeping. I mean, look at this. The amount of waste is just staggering. On average, across the entire industry, GPU utilization is somewhere between a pathetic 15 and 25%. Think about that. It's like buying a whole fleet of Ferraris and then only using them to drive to the grocery store once a week. It's an insane financial drain, and Ivan is the poor guy who has to answer for it.
But now, let's flip the coin. Let's talk about Diana, the data scientist. So, while Ivan is pulling his hair out over all this idle hardware, Diana is literally just staring at her screen. She's been stuck in a digital line for 2 days straight, and all she needs is one GPU to test this idea that could be a total game changer. The tools she desperately needs are right there, locked away, and they're not even being used. So you've got idle machines over here and brilliant, frustrated people over there. It makes no sense at all.
So, how in the world do you fix this kind of chaos? Well, from Ivan's point of view, he needs to lay down the law. See, the usual schedulers, like the one baked into Kubernetes, they were built for normal, predictable web services. They have no idea how to handle these massive, bursty AI jobs that need a ton of power all at once. You need something different, something specialized that has a real all-or-nothing attitude to bring back some order.
And that something is called gang scheduling. Here's how Ivan sees the problem. If Diana needs, say, 8 GPUs for a huge training job, a standard system might grab the 7 that are free right now and then just sit there. It waits and waits and waits for that 8th GPU to free up, holding those 7 GPUs hostage so nobody else can use them. It's a complete deadlock. Gang scheduling just says, nope, we're not doing that. The job doesn't even start until all 8 GPUs are free and ready to go at the exact same time, period.
To make this crystal clear, Ivan's got this great analogy he uses. Just think of your big AI job, the huge model Diana's trying to train, as a professional basketball team. Simple, right? You can't start a real game with only 4 players. You need all 5 of your players on the court, ready for the tip-off. And in our world, those players, they're the GPUs. If your job needs 5 GPUs, it needs all 5. No ifs, ands, or buts. And this is the perfect picture of the problem. Having 4 players just standing around on the court waiting for that 5th guy to finally show up, that doesn't just stop your game, it means no other team can use the court for anything. That's deadlock. It is pure, infuriating waste. So here's the solution. Gang scheduling is like a smart coach. It keeps the entire team on the bench until all 5 players are warmed up and ready to go. The second they are, boom, they run onto the court, they play their game, and then they get off so the next team can play. The court, which is your incredibly expensive GPU cluster, is always being used for an actual game. Okay, so gang scheduling is awesome for those gigantic jobs. It totally solves Ivan's efficiency problem. But what about Diana? Sometimes she doesn't need a whole basketball team. She just wants to run a quick test, do something interactive. She definitely doesn't need an entire, super powerful GPU just for that. And this brings us to Ivan's other favorite analogy. Giving a whole NVIDIA A100 GPU to Diana for a simple experiment is, well, it's like forcing you to buy an entire extra-large pizza when all you really want is one single slice. The rest of the pizza just goes to waste, and that kind of thing drives Ivan absolutely crazy. This is where things get really cool. With something called software-defined fractioning from a company like Runeye, Diana can ask for just a tiny piece of a GPU. She can say, hey, I just need 1/10 of that pizza. And the software carves out that little slice just for her. And it even gives her her own protected memory space, so her work doesn't mess with anyone else who's sharing that same GPU pizza. Now, for the really technical folks watching, you might be thinking, hey, what about NVIDIA's own MIG technology? And that's a totally fair question.
MIG is great. It splits the GPU at the hardware level, so it's super secure. But it's also really rigid, and it only works on the newest, most expensive chips. The software approach, on the other hand, is way more flexible. You can change the size of your slice on the fly, and it works on all those older GPUs that, let's be honest, most companies are still using.
So we've solved the big jobs with gang scheduling and the small jobs with GPU slicing, but now we have to tackle the hardest problem of all, the people, the politics. How do you fairly decide who gets what when you have 10 different teams who all think their project is the most important thing in the entire universe?
Ivan solves this with a pretty brilliant three-part system. First, every team gets a guaranteed number of GPUs they own. That's their quota. Second, if your team's GPUs are just sitting idle, another team can borrow them. This is how you push that utilization metric way, way up. And third, and yeah, this is the controversial part, is preemption. If the team who owns that GPU comes back and needs it, the system automatically and brutally kicks the borrowing job off.
Now, I know what you're thinking. Diana would absolutely hate the idea of her job just being killed right in the middle of her work. But the system is actually really smart about this. It understands the type of work you're doing. If Diana is in an interactive build session, actively coding and testing, that job will never get kicked off. But if it's a long overnight train job that's just running in the background, yeah, that can be safely paused and restarted later. And of course, live inference jobs in production are always protected. It's a tough system, but it's fair. So we've got this really elegant system for managing the technical chaos, for sharing resources efficiently, and for navigating all the office politics. And the biggest validation for this entire way of thinking, it came in 2024, when NVIDIA themselves stepped in and bought Run AI.
From Ivan's perspective, this was a huge signal. This means NVIDIA isn't just a hardware company anymore. They're not just selling chips. They are building the entire software stack for AI. They are becoming the Microsoft of the AI data center, offering a single integrated platform that gives him total control and visibility.
And for Diana, this is basically a dream come true. This whole move promises a future where getting access to a GPU is as simple and seamless as connecting to the Wi-Fi. It means less friction, way less time wasted in queues, and a lot more time actually inventing the future.
So, after all this, the back and forth, right? Ivan's obsession with utilization versus Diana's desperate need for access? Who actually wins in the end? Is it the IT admin trying to control costs? Or is it the data scientist trying to innovate at the speed of light?
Well, when you look at the final scorecard, it's pretty clear this isn't a zero-sum game. Ivan gets exactly what he wants: total cost control, complete visibility, and that beautiful, beautiful 90+% utilization number he can show his CFO. And Diana gets what she needs most: fast, fair access to the tools that let her do her job. Everybody wins.
And that kind of leaves us with one last big question to think about. As we build out these incredible new AI factories, what should be our true North Star? Is it about squeezing every last ounce of efficiency out of every piece of hardware? Or is it about creating an environment where those breakthrough, world-changing ideas can spark in an instant? The real answer, it seems, is finding that perfect, delicate balance between the two.